Welcome back to Agrinova, your trusted YouTube platform. Thank you guys for supporting. So today's topic we will continue, that is remote sensing. So let's start. What do you mean by remote sensing? So basically we know that we have studied in last lecture about precision farming, and we know precision farming has 7 to 8 components, from which remote sensing and GIS are main of them. So basically remote sensing and GIS are interrelated technology which has revolutionized the way to study the natural environment and agriculture. Okay, so basically what do we mean by remote sensing? Let's see the definition of remote sensing. That is, it refers to collection of data. Means basically the collection of data from the source, that can be the GPS or any other software. So it refers to collection of data about Earth's surface without direct contact, means without getting in direct contact, which can be basically seen as its satellite. So we will further know about the remote sensing in detail with the help of diagram. So what do you mean by remote sensing? It refers to collection of data about Earth's surface without directly getting contact, typically by sensors or satellite or aircraft or drones. Okay, then what is GIS? As I told in last lecture, the GIS means it is a powerful tool which stores, manipulates and analyze or visualize geographic data. Okay, so let's see about the remote sensing stages. So basically assume this as sun. I know it's not looking like a sun, but we have to assume it's sun. So basically this is sun, this is the vegetation, a person, this is the satellite, this is the receiver, and a computer desk where main operations are taken. So basically here sun is source of energy or illumination. Basically remote sensing begins with energy source, usually sun or any other artificial like radar. Basically its purpose is the sun emits EMR radiation. Okay, means electromagnetic radiation that interact with Earth's surface, whether it can be a person or any vegetation, plant or animal. So sun emits EMR radiation which interacts with the Earth's surface. The traveling EMR radiation can be absorbed or scattered back or even reflected. Okay, due to atmospheric condition like dust, cloud, gases or any other reflective material which can be snow. But some of the energy can be transmission or pass through, example, water. So water can transmit energy to another object. So the reflected energy gets back to the satellite again, which here does the recording of energy through its sensors. That can be passive sensors or active sensors. So basically what do you mean by passive sensors? That is the natural radiation. So basically the passive sensors are natural radiation. Okay, and the active sensors are the radiation which emit their own energy and record the return signal. Means basically they are self-creating energy radiations and self-recording. Then after receiving and recording the energy by sensors in the satellite, it transmits further to the ground level station, which further does transmission, reception and processing of the received or the recorded data. Further, the data is interpreted and analyzed by the system, where visual interpretation and data analysis and its application is done through various software. Example, AirDAS and NV are some of the software which does image processing or image interpretation. And all this, and after this, the received data which has interpreted, it can be converted into meaningful information for various application in the field of agriculture or forestry or disaster management. Or environment monitoring. So now we have got a clear image how stages of remote sensing works. So let us see that what are the tools of remote sensing. Basically there are 4 tools of remote sensing, that is platform, sensor and software, and the last one, that is the GPS and GIS, which are integrated or which are in integration. So let's start with the first tool, that is platform. First, the platform can be divided as, it can be the satellite based, aerial based or ground based. The satellite based platform, that is IRS, the Indian Remote Sensing Agency, which works under ISRO, operates it with its satellite. And another example of satellite based, that is the Landsat, which is operated by US's NASA. Okay, then the aerial sensor or aerial platform, that can be drone, which receives or which transmit the signals or the information to the ground. Then the next platform can be the ground based tower presented on the surface of earth, which receives or transmit the signal. Second, the sensor. The sensor can be the optical, thermal and microwave or radar sensor. So basically optical sensor example are LIS, that is linear imaging self scanning sensor. Okay, and the second sensor which detect the reflected sunlight, that is MODIS, that is moderate resolution imaging spectroradiometer. So basically they detect the reflected sunlight. Then the thermal sensor, thermal means related to heat. So basically they detect the emitted infrared radiations. The next, the microwave or radar sensor, that is the RISAT, basically is radar imaging satellite. Which helps in crop health monitoring. So basically these are some of the images which are detected or interpreted by the sensors, and the color patterns are formed. So basically this pattern, we can say there is the healthy vegetation, rather than this reddish pattern detects some of the problems mentioned. Next, the software. I have told that eRadars and NV are some of the software which are used in image processing and image classification and spectral analysis. So what do you mean by spectral analysis? Let's see. So basically spectral analysis in remote sensing is the process of analyzing. So basically if there is an artificial based platform, that is area platform, whether it is drone, so it receives the signal and does a process of analysis of an object or object's electromagnetic radiation, which can be passed to the receiver in the form of a chart, which can be seen as colorful chart representing various colors and spinning. Basically these colors are different wavelength identified on the map with its properties, specific properties. So here you can see that the green wavelength represent the healthy crop, the red that is represent the stressed crop, the green the light green represent the nitrogen deficiency, and black, that is the necrotic conditions. So by this way, spectral analysis by various softwares can be done, which identify potential problem of the farmland. So basically, next, the fourth component or the fourth tool, that is GPS and GIS in integration. So basically, GPS is geopositioning and geotagging, and GIS is data layering, we know, analysis and mapping. So let's go forward. So what are the tools of remote sensing for ecosystem analysis? So basically, remote sensing as a tool for ecosystem analysis. So how remote sensing help in ecosystem analysis or to save our ecosystem or environment? So let's see one by one. So first, it can be used as land cover mapping for basically mapping purpose, okay, or classification, to classify different area and provide a solution for specific conditions. Second, it can also be used for climate change studies. Think of your own that how remote sensing can help in the field of ecosystem or environment. So it can also help us to study about the wildlife and vegetation study and solve the disasters and protect our biodiversity. It can also detect the invasive species So we know we have a major problem, that is a climate change, in which in the urban areas the major problem is increasing temperature. So it can detect the urban heat island effect caused due to temperature rise or global warming. Then it can be also done for studying the watershed and its management. It can be done or used for assessment of natural disasters. So we can be prepared before the disaster takes place. So basically, by this way, you can generate more points and can be used in your answer as remote sensing advantages, benefits, or as a tool in ecosystem or environment analysis. Okay, so let's go forward with the components of GIS. So basically, we know GIS is for data storing, analyzing, interpreting, or interpretation. Okay, so let's see first the hardware and software. So we know with basic computer knowledge what do we mean by hardware, that is the computer system or the technical setup or the network where GIS operates. So basically, example of hardware is computer system. Or any technical setup which is required for the GIS operation. So the next component, that is the software. So basically, the software used for data management. So software helps us in analyzing and displaying geographical information. Okay, and also storing. the next component, that is the data. So after hardware, software, there is data. Basically the data that is spatial, which can be in vector, raster or image. So if you have any queries, please search on Google what do you mean by vector, raster or image data. So basically these are type of data which can be analyzed. The other data, that is non-spatial data. So spatial and non-spatial, that is attributed data. Basically it is the descriptive information related to geo features, that is geographic features. Okay, then the people are the main component which can be seen as the people, that is the handling expertise. Okay, which can be researchers, analysts, technicians, which solve the problem, ask the question, choose, collect, analyze and interpret the result. Okay, then last, the method or the procedure through which we opt or interpret the data. So they are basically guidelines, methods, principles, okay, which are applied to GIS. Okay, by this way we have covered the components of GIS, which are hardware, software, data, people and method. So basically the last part, which is the important and asked in several times in the exam, that is GIS and RS, that is remote sensing used in agriculture. So with up till now, with sufficient knowledge, I can say definitely you can answer the question with 100% accuracy. So let's see what are the applications of GIS and remote sensing in agriculture. So basically it can be used for crop acreage and production estimation. Okay, then what is the next? We can also estimate or assess a crop damage or crop progress. Then is the identification of pest and disease. The next, we can also say that it can be used in crop health analysis. It can be used in precision farming. The next, it can be used for the same which we used in environment, that is land use and land cover mapping. Also, which is the important, that it is used in soil moisture estimation. So basically these are the some of the components. You can add up more components by your own knowledge or searching, whether it is on Google or ChatGPT. So using ChatGPT is the need of the hour. So basically these are the most common point how you can value at this point. Basically everyone is gonna writing these same points, or repeatedly the examiner is going to check the same points again and again. So the differentiation of your answer must be the most important. That by these writing the short examples, that is, if you have written the point precision farming, you can write it for site specific nutrient management. So here everyone is going to write about the precision farming, the use of precision farming. Okay, so by this way, writing more specifically that site specific nutrient management, you can score more marks. Then again, the crop health analysis. So how crop health analysis? So basically using the software, that is the Fasal or the Fasal app, which help in forecasting, or using used in agrometeorology to assess the further environmental or climatic conditions which impacts the crop health, or any other app, that is Plantix. Okay, like this way you can value add your answer searching it on Google or ChatGPT. So basically we are done this for today. Thanks for watching. Thanks for supporting. Do share this video or our journey to your colleagues or nearby friends, and do suggest for more topics, that what should I take further, or which series I should start, and also comment your view on the topic, and do subscribe and share to your friends. Thank you.